Hola, hi, this is Al, your statistics instructor. Let's get to work. In this video, we are going to talk about the event composition method. To be more specific, we will discuss an example to illustrate the ideas behind this method, the event composition method. Okay. Well, I will borrow this example from our lecture notes. Okay, take a look at it, scan it quickly, and then we're going to see what this is about. So, we have a medical clinic and we want to study a waiting line. Okay, we have, right, according to the records of this clinic, that the probability that a new arrival is an emergency is 1/6. Okay? Okay, now the ultimate goal is finding the probability that the rth arrival, the rth patient, is the first emergency case. Okay, so basically what we want is a formula to find that probability. That would be the ultimate goal. Okay, now we are going to make a few assumptions here. We're going to assume that patients are independent, and independent in the probabilistic sense. Okay, so let's get to work. Again, bear in mind that the ultimate goal is finding a formula for this probability, the probability that the rth arrival, the rth patient, happens to be the first emergency case. Okay, so one of the main ideas behind the event composition method is we are going to be defining some simple outcomes, okay, and then using those simple outcomes we are going to come up with the events of interest. Okay, good. So that's one of the main ideas, using these simple outcomes as building blocks for more complicated events. Okay, so in this case I'm using BI to denote the following event. The ith arrival is an emergency. Okay, and again, according to records from this clinic, they think that this is a reasonable probability for that event, that the probability that the ith arrival is an emergency happens to be 1/6. Now, the complement of BI complement would be that the ith arrival is not an emergency. Okay, and we know because we talked about this, right? We actually showed this result, that the probability of the complement of an event is 1 minus the probability of the event. So in this case it would be 1 minus 1/6, meaning 5/6. Okay, And again, reminding us that the ultimate goal is we want to find a formula to compute the probability that the Earth arrival, the Earth patient, is the first emergency. Okay. So let's do it step by step. So first, let's try and find the probability that the first arrival, the first patient, is the first emergency case that they see. Okay, so note that in order to have that event, that the first arrival is the first emergency, what we need is the probability of B1, meaning that the first arrival is an emergency, and the probability of B1 would be just 1 over 6. Make sense? Okay. So probability of B1, and we know from the information that we have that that probability is just 1 over 6. You guys agree? Okay. Now let's try and do something similar, okay, with the second patient. What is now, we are going to find what is the probability that the second patient happens to be the first emergency. Let's find this probability. Let's think about it. So remember, our building blocks will be the BIs. Okay, so if the second patient is the first emergency, what that means is that the first arrival was not an emergency, right? And then we had to wait until the second arrival to see our first emergency case. Make sense? So again, we are going to try and write or express this event. The second patient is the first emergency case in terms of the BIs. So again, if the second arrival will be our first emergency case, what that means is that B1 was not an emergency, and then B2 is the emergency. Okay, so again, we're using those BIs as building blocks. So let me go back to what we had here. So again, this event, the second patient is the first emergency case, is equivalent to B1 complement intersection B2. Okay, and now since we're assuming that these guys are independent, then this is going to be the same as the product of these individual probabilities, right? This times probability of B2. Okay, and then we know that the probability of any arrival being an emergency is 1 over 6. So we're going to have 1 over 6 here, and we're going to have the complement here, right? We're going to have 5 over 6 here. Let me write it down like this. 5 over 6 times 1 over 6. Another way of writing it, another way of writing this down would be like that, right? Let me do it like that, okay? It's the same, right? But I just want to stress that property, that the probability of the complement is 1 minus the probability of the event. Okay. Now let's try and do this for not for the second patient, but for the third. So what's the probability that the third patient is our first emergency? Okay, so again we use the same idea, right? We go, oh, if the third patient is the first emergency case, what we have is something similar to what we had here. Let me be lazy and I will copy and paste this. So what we have is that the first arrival was not an emergency, and we also have that the second arrival was not an emergency, and finally the third arrival is the one that happens to be our emergency, right? And then again, hey, we have the probability of an intersection, okay? And then by independence, the probability of an intersection is, you know, the product of those individual probabilities. So let me copy and paste this. This is the probability of B1 complement times probability of B2 complement times, times probability of B3. But that just happens to be 1 minus 1 over 6 times 1 minus 1 over 6 times 1 over 6, right? So let me write it down. Let me copy and paste this. Note that now, instead of having 1 over 6 just once, we have, instead of having 1 minus 1 over 6 just once, we have it twice. We have 1 for this complement times another 1 for this complement. So we have this term 1 minus 1 over 6 square, right? Can you see it? And then probability of B3 being an emergency, just 1 over 6, right? Let's do one more for the fourth, and then we're going to jump and come up with the formula for the rth arrival being the first emergency. Okay, so let's copy and paste this. So now we want the fourth patient is the first emergency. Again, we use our BIs as building blocks. If the fourth arrival is the first emergency, then the first 3 arrivals are not emergencies. And finally, the fourth one, that's our that's our emergency. Okay, again we use independence, and then what we have is the probability of B4 here. We have to change this. Now this guy is a complement, so we have probability of B1 complement 1 minus 1 over 6 times 1 minus 1 over 6 times 1 minus 1 over 6 times 1 over 6. So we have 1 minus 1 over 6 cube times 1 over 6, right? So now we're ready to come up with the general formula. So the probability that the rth patient is the first emergency is this, blah 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 blah, right? And then we have dot dot dot, right? How many of these we're going to have? Oh, that means that the first r minus 1 cases were not emergency cases, right? And then the rth case is our emergency case, right? Same ideas hold, right? And instead of having 3 non-emergency cases, we have r minus 1, and then the rth is the emergency. Make sense? Okay, so let's just summarize what we did here. So we were interested in this event, that the rth patient is the first emergency case. Okay, so what we did here is we came up with simple events, right? The BIs, and then using intersections and complements, in this case, we were able to construct the main event of interest, and that's the main idea behind the event composition method. Okay, well, that's it for now. Thank you for watching. Please take care and keep working hard. See you next time. Bye.